Hey, welcome to another exciting session of Python programming. We've revised the file that we've been working with a little bit. Instead of class something, I've changed it to patient, very pertinent in the COVID-19 crisis. And one number is the pre-treatment oxygen level, and another number is the post-treatment oxygen level. So what we're going to do is evaluate the difference between the oxygen levels pre and post treatment. We continue to have getter methods which will, when asked, return the name, the number, and another number. And instead of just a collection of somethings, we have a collection of patients. And we've added some things here. We have the list of items, really ought to be named patients. We have the mean, the differences from the mean, and as well, the differences between the first oxygen level and the second oxygen level, the standard deviation, and the z-scores. So you might want to pause the video right now and go ahead and look at Math is Fun, and you can simply look at using and handling data. A lot of what I've done here is from here calculating out a mean or an average and calculating out the standard deviation. So I'm not going to go deep into the weeds, except to say that this is used to measure whether or not there's some difference between the pre and the post treatment with regard to oxygen levels. Again, we have an add item method here, and I'll share this file. Which incidentally will run on the web in tutorial point, and you add to the list of items each patient. And so you can see down here where I'm adding item, patient number 1 with a pre-oxygen level of 75% and a post-oxygen level after treatment of 95, 25, 10, 63, 72, 56, 89, 57, 62. These are 20 patients in their pre and post oxygen levels. And you can see I've created a collection of patients and added each item. So let's run it and take a look at what's going on. So the part that won't work in tutorial point is actually this graph, which shows that the distribution of the patients is not normal, because normal would be sort of a peak right in the middle and drop off at either tail. So these are the differences, the raw scores of differences between the pre and the post number. So sometimes it's pretty remarkable. The average difference is 18.35, and the standard deviation is 11.70. We'll talk a little bit about standard deviation, but if you've had a statistics class, you might know already. And this last printout is the printout of the z-scores. So we'll go back in and dive under the hood a little bit. Why I chose this? Because if you look at it, it is a series of algorithms that use math that depend on each other in order to arrive at a meaningful result. So the first thing that I'm going to do is find the difference, and I'll iterate through the items list and calculate out the differences between the first number and the second number. Notice I'm using the absolute value of the differences between the two numbers, and I'm also using the accessor in the patient class. I print it out mainly as a way of looking at it. Then what I do is calculate out the mean. I go through the differences and I come up with, after totaling them, the mean difference, and I print it out. And a mean is just another way of saying the average difference between the pre and post treatment. Once I have the mean, I can calculate out the standard deviation. And the standard deviation is calculated by coming up with a variance between the differences and the mean difference and squaring it, and then dividing that squared variance sum by the number of values. And the standard deviation is simply the square root of that variance. So I print it out, and we can do that. Finally, I come up with the z-score calculator, which is the differences minus the mean divided by the standard deviation. We'll assign a z-score, which is a measure of how far it is from the mean. And so it's a measure of deviance from the central value average. So taking a look at that again, okay, what you'll find is that supposedly 68% of all values should fall within one standard deviation from the mean. So that would be -1 to 1. And gee, I just kind of don't see all 68% of values falling in between -1 and 1. Maybe a little more. Anyways, the point is that if I was a real epidemiologist, I would examine this a little bit more in detail. So I'm going to upload the file and share it with you. You can take it apart and look at it, but it's a classic example of one, using abstraction, patient, and collection of patient to manage the complexity of the program, and as well in collection of patients using different algorithms that are independent on each other to perform the work of the program. So these definitely use mathematical concepts, and basically is an idea where if you apply this to yourself, you'll and your example really come up with a winning solution. So that's today's lesson. There's really nothing to do particularly. I wouldn't ask you to try to replicate this on your own, but I'm still waiting for you guys to create a program with a base class that also has a collection of those objects created by the base class, preferably in a list. So if you want to know how to do that, look at the previous videos. This is Max out today. Have a good one.